All right. So first of all, as a reminder, tonight is our virtual tech talk with David Vilwalk from Komatsu Industries. It's on Professor Josh Locklear's Zoom room. If you want to scan it, you can scan it here. Otherwise, it is up on Slack, I think, in the general channel. That's tonight from 6 to 7 p.m. I would highly encourage you to attend that. It is going to deal with artificial intelligence and things like that related to the mining industry. So, kind of an industry you would not have necessarily thought there would be a lot of computer science stuff associated with, since they're mostly digging in the dirt. But shockingly, they've had things robotically run with artificial intelligence for years. So, I think that'll be pretty interesting. So, having a and this Komatsu place is also offering internships as well as full-time employment. So something you certainly want to show up to. And I'm guessing he'll give some contact info where you can send resumes or something like that. Questions about that tech talk? All right. So then let's jump into our uh, thing. So we are finishing writing our on roll button clicked function such that it updates the appropriate text views on the user interface with the correct quantity and total sum of all the rolls. All right, so let me open up Android Studio. And just as a reminder, here's our user interface. The idea is that when we click the roll button, we want to roll this many of these sided dice. And what we want to do is we want to store each of those individual rolls somewhere so that we can populate this text view with those. And then we also want to sum it up so that we can populate this text view with that. So we need to decide how many sides are we rolling and how many dice are we rolling. And then we need to create a collection for those. And what have I already given us? Okay. So here's our quantity string. And then here's the quantity integer that we parsed out of that. So this is the number of things, number of dice we're going to roll. And here's our array for holding those guys. And then here is our dice string for which dice was selected. And then we trimmed it down to just a 4 or a 6, something like that. And then we have our number of sides, which will be the integer version of that. All right. So now we're going to use our random number generator to generate a value between 1 and this value inclusive. So if it's a 6-sided die, I want to give some random number between 1 and 6. If it's an 8-sided die, I want to give some random number between 1 and 8, so on and so forth. All right. So, and we want to do this some number of times. So we're going to say for int I is equal to 0, I is less than quantity int number of times, or I could also say the rolls dot length. Both of those guys are the same value. Okay. I did share my screen, right? Yep. So both of those guys are the same value, and then we'll say I plus plus. So we're going to do something that number of times. What are we going to do? Well, we're going to roll the dice, and we're going to add it to bucket I of our the rolls. So we'll say the rolls at bucket I gets the value. So now we need to roll a random number. So if I say r dot next int, and I give it the number of sides int. So for instance, if I gave it a 6, that's going to give me a number between 0 and 5. So if I want to make it a number between 1 and 6, I need to add 1 to the result of that. So r dot next int, number of sides int, will give me a value between 0 and the number of sides minus 1. And then if I add 1 to it, it'll give me a value between 1 and the number of sides. I'm going to go ahead and store that inside of my roles at bucket I. Now, I also want to build up some information here. So I want to get my total. So I'll say int total is equal to 0. And then I'll say total is equal to total plus the roles at bucket I here. This is going to be for my running total. Now I can also build up my string for this guy. So I can say string individual roles, and I can start that off as the empty string. So now I can do something like, since I want to have it like a role followed by a comma, followed by role, followed by a comma, I could say if it's the empty string, so if individual roles dot length is equal to 0, then we'll say individual roles is equal to the empty string concatenated with the roles at bucket I. So we'll just store the very first value in there as a string. Else, if I already have some stuff in that role string, because again, I'm trying to make it look like this up here. So this would be a role plus, oh, I'm not comma separated, but I guess I have plus signs there for it. So this would be a role, and then the next thing would be a space, plus sign, space, the next role, space, plus sign, space, the next role, so on and so forth. So if it's currently empty, I'll just put a single role in there. Otherwise, I'm going to say individual roles is equal to whatever it is currently equal to. Concatenated with a space, plus sign, space, concatenated with the roles at bucket I. So we're building up that string either way. So I am storing my individual roles in case I want to use those for something. And then I'm getting my running total, and I'm building up my string that shows those individual roles. When this for loop is done, I should now have the two things that I need to put. I need to have something that I need to overwrite this text field or text view with one string, and this text view with my totals as a string. All right, and did we hook these guys up yet? All right, I don't have them hooked up yet. So I'm going to go ahead and create a couple of more variables. So I'll say private text view. I will just make these global so we have access to them throughout the program in case we want to use them in other places. Otherwise, we certainly could have just made them local variables inside of role. But I'll say private text view, and I want to name it the same as we have it out here. So this guy is called roles TV. And then we'll have a private text view. And what's the other guy called? He is called Total TV. And then I'll go ahead and set them up in here. So we'll say this dot roles TV is equal to this dot find view by ID r dot ID dot roles TV. And this dot total TV is equal to this dot find view by ID r dot ID dot total TV. And that was the thing I was suggesting that you didn't do, Trevor, that you forgot one of these. I replied to your thing. Oh, okay, gotcha. So it was giving you an error on what a button was. Gotcha. Because it didn't know what a button was. Okay, got it. All right, but common mistake here is just because I defined a variable up here, that's only the first half of the MVC connection, right? I need to have a variable for it, but this is where I actually link that text view to something that's on my interface. So make sure you complete those two steps, because if you don't do that, This guy is just a variable that currently holds nothing. He doesn't actually connect to something just because he has the same name as it. I'm only naming him the same because it just makes sense. I named it something on my interface called roles TV because it's my text view for holding the roles. So I'm naming it the same thing here because, well, that's the same reason I named it that thing over there. But you don't have to name them the same. So the connecting piece is this line right here. This is where we're saying I want this local variable to be associated with this actual view that lives in my interface. All right. So back down here. So now I have my two things set up. So I can go ahead and say this dot the roles, or what did I just call it? Roles TV, set text. And I'm going to set this guy equal to individual roles. I've already built up that string. And then I'll say this dot total TV dot set text. And this guy's currently an int, so I'll just set it to the empty string concatenated with total. All right, so that's the logic that should happen when we click our roll button. Okay, so grab our quantity, grab the number of sides as an int, then go through quantity number of times, roll the dice each time, store that roll in case we need it later, but build up our running total and build up our string that has the number separated by plus signs. And then ultimately set those text views equal to the right stuff. Let's go make sure we set our on click for that roll button to on roll button pressed. Come out here, roll. Yep, I already have it set up. So this guy should now be good. I'll go ahead and run this. All right, so if I want to roll 12 D4, I get my 12 individual rolls. Sum is 30. If I want to roll 7 D10s and I roll again, this is going to roll 7 D10s and give you my total. All right, makes some pretty good sense. All right, now let's say, so I think that completes the homework assignment. All right, so that was the, let's say, an answer for the homework assignment. So I'll go ahead and actually commit that. Solution for what homework was it? 15? All right. What's up there? All right, so that's pushed to GitHub. Then next thing, well, I'm going to show you how to do like a little error message type thing first. That would be kind of helpful. When I first run this, our interface looks like this. So we probably want to empty out this text view. We probably want to empty out this text view initially, right? We don't have a bunch of roles. We built our interface with this in mind so that we have kind of a visual what each thing is, but let's go ahead and get it in a little bit better starting state. All right. So we'll go into our code here, and up top where we first initialize them, just like we did here, we'll go ahead and set this dot roles TV set text equal to the empty string, and this dot total TV set text equal to the empty string. So that'll zero out those two things. So they're empty. We'll go ahead and run this again and just see that we have accomplished what we were trying to accomplish there. All right, so far so good. Now we probably also want to have this guy empty out, right? We haven't selected a D6. Now we could assume that they already clicked D6 or something if we really wanted to, but let's just have it empty at first. So that guy is called selected die TV. And we'll set that equal to the empty string as well. Run this again. Okay, so looks like we have a kind of a decent starting point for our app. But what happens if I click roll right now? It's going to try to parse an integer out of here, and there's no integer there. It's going to presumably gets past that hoop. So I'll go ahead and hit roll. We crashed, right? Bad news bears. If I go in here to my logcat, let me just get rid of this. We should see an error message down here. Number format exception for input string, empty string. Don't try to parse int, nothing. Parse int requires something that's numeric. So maybe we go ahead and we have a couple of checks to make sure that we're prepared to roll before we actually roll. So inside of this on roll button pressed, maybe we're going to find out, do we have everything we need to roll? So the first thing is we need a quantity, right? So the quantity is in the quantity TV get text. Now we know that that will hold a numeric value, if it holds any value, right? We rewrote the code for that calculator part. Remember last time we made it so that it can't start with a 0 and only attacks on things associated with those buttons. So we know that if it has anything in it, it's a number. So we don't have to check whether it's numeric, but we probably want to check to make sure something's in there. If there's nothing in there, that means we haven't dialed in a number yet. All right. So we'll go ahead and ask the question, if this dot quantity TV, actually, I can go ahead and do this. I'm going to get my quantity string up here. I'm also going to get my full dice string up here. Those are the two pieces of information I'm going to need in order to determine whether the rest of this is a go. Make sense? All right. So I'm going to first ask the question, if quantity string dot length is equal to 0, that means that we did not enter a quantity yet. So we want to give them some kind of error message. All right. So let's just do something like we'll have a string error message. Start that guy off as the empty string. And we'll go ahead and say, well, if that's the case, then error message is equal to you must enter a quantity before rolling. Something like that. Else if, so let's say they maybe did enter a quantity, but they haven't selected a dice. So then we'll say, if full dice string dot length is equal to 0, that means they haven't selected a dice yet. Going back here. Oh, we crashed on that. Going back in here. If this guy has nothing in it, we didn't select a quantity. If this guy has nothing in it, we didn't select the dice. So if that's the case, we will say you must select a, I'll say dice, even though officially it's die, D-I-E, but we'll say dice before rolling. All right. Now, I could do this whole thing as I can say, this stuff, show our error, else do all this. But I'm going to take advantage of something we talked about last time where the return function makes a method immediately end. So I'm just going to ask a question. If error message dot length is greater than 0, if I have something in my error message, let's go ahead and show the error and then make this method end. We're not going to do any rolling. Okay, so basically this guy is kind of like a landmine, right? If we get past that, that means that everything was set up. We can go ahead and start parsing integers and stuff out of here. But if I get trapped into this guy, that means one way or another, I have an error message set. I want to go ahead and show this error message somehow. Okay, we're going to talk about that here. And then I want to get out of Dodge. So the last thing I'll do is I'll return. This says immediately end this method. Don't try to do any rolling. All right, but before we do that, we're going to create something called a toast. All right, so in Android, we can have things just kind of pop up on the screen for just a delayed period of time. You can have it be kind of a short toast or a long toast, and we'll see that here in a second. So sometimes you'll get error messages that pop up on mobile apps. It'll say, you must do this, and you actually have to hit OK, right? Where maybe with this, we say, you know what, I'm just going to say, you gotta use the interface right before we let you roll, but I don't want you to have to click on anything. I just want to scream at you real quick. All right, so that's where toast comes in. So we have an object called toast, and we have a function called make text. And the make text function requires us first to give it a context. Okay, the context is, for lack of a better explanation right now, it is the activity in which this toast should occur. So that means that this is the context. All right, now it wants our message. Our message is error message. All right, then the third thing is it wants to know how long it should be. So I have something in here called toast. We'll do length long. All right, so this just creates a toasted text. So toast is kind of like when you're at a wedding or something, you're like, I'd like to propose a toast, something like that. I think that's where it kind of came from. But now the last thing we need to do is we do need to make sure that we show that text. All right, let's see this happen first, and then we'll come back and we'll decompress this line. So I'll go ahead and run this. All right, so if I were to click roll right now, it's going to scream saying that I need to put in a quantity, right? So I'll go ahead and hit roll. You must enter a quantity before rolling. Shows up down there, and then it goes away. So if I go ahead and I put in my quantity and then I hit roll again, I haven't selected a dice yet. It says you must select a dice before rolling. So I'll go ahead and select my D12 and then I'll hit roll, and now it just works. All right, makes sense? So we see what toast does. All right, but now we want to take, so this is the first time, I'm guessing for most of you, this is the first time you've seen the Android widget called Toast, right? Okay, but we should already know a bunch of stuff about this guy just by looking at this. This goes back to the question on the exam that talked about, class methods versus instance methods. How can we tell the difference between a class method when we see it being defined? How do we see a class? How can we tell if something's a class method when we see it being used? Instance methods for both of those as well. So we want to kind of look at this line. So I've shown you a line that now works, but I want you to tell me what each thing is. So what kind of animal is make text? If you had to describe for me the kind of thing make text is, what would you say? Let's just get a couple of characteristics. So in the world of programming, what kind of thing is make text? This guy right here. It's a who? A string? What am I trying to do here? What does these parentheses tell us? This guy right here. What are these parentheses indicating? Here, we'll go with something maybe more obvious. What is show? What's that guy? That's what it does. It shows something on the screen. But what is it? Is it a variable? Is it a method? Is it a class name? What kind of thing is show? A command? Tell me more. What's a command? We're looking for programming terms here. In fact, I'll give you your choices. I already gave you them, right? Class name, field, method, constructor. Which of those four things is show?
Is it a method?
It's a method. Okay, how do you know it's a method?
Because it has parentheses and it like does something, or it's calling to like somewhere else in the code.
Okay, well, so at the end of the day, it's because it has parentheses, right? This guy, the kind of animal this guy is a method because it has a parameter list. All right, it has a parameter list. We know it's not a constructor. Constructors kind of look like methods because it doesn't seem to match the name of a class, probably because it's lowercase. Okay, so when we see something that looks like this, as programmers, we should be able to immediately identify this, even though we haven't been introduced to this before, as the kind of thing this is a method or a function that takes no parameters. That's what that is right there. We might not know what it's accomplishing. We might not know what it does, but that's what it is. Similarly, make text. Along those same lines, what kind of animal is that guy? Using that same logic we just talked about, what am I looking at here with make text? Is it a field? What are fields? When I talk about object-oriented programming, what is a field? Can't emphasize enough how important these kind of concepts are because they unlock the entire programming language to you. These are the things that will allow you to go from programming language to programming language to programming language and quickly pick it up. Okay, because these things go between languages. Same thing. We talked about static versus non-static. I emphasize that as super, super, super important, right? It was represented as 10% of the midterm exam, in fact. Okay, and it's probably more important than that. It's probably like I think I probably said it's like in the top 3 most important things when it comes to programming. So if I'm looking at make text here, we just broke down what show is. So what kind of animal is make text? You got the same, go ahead. I'm not asking what it does. I'm asking what kind of animal it is. Is it a constructor? Is it a field? Is it a method? It's a field. Okay, tell me what a field is first. Okay, so a field is a variable associated with a class. Okay, what makes you think this is a field? Okay, hold on. I'm asking a question about that entire thing as a single thing. Everything I have highlighted as one thing, I'm asking what kind of animal that is. Something he just pointed out is he said, this dude right here might be a field. We're getting to that. All right. Okay. But we're decomposing this line because this is something we need to be able to do as a programmer. So everything I have highlighted right here is a single thing. What kind of thing is that? Is it a constructor? Is it a method? Is it a field or is it a class name? Should be able to follow the identical logic to what we did right here. What did we say over here? We said, well, it doesn't start with a capital letter, so it seems like it's not a constructor. We said that it has open and closing parentheses, so it has a parameter list. Does this guy not start with a capital letter? So it doesn't look like a constructor. Does it have an opening and closing parentheses? Yep. So that's a parameter list. So he must be a method. Okay, he's a method. You should be able to look at this instantaneously and say, is that a method? It is. Follow-up question, is it a class method or an instance method? This comes down to that question on the exam that said, how can you tell the difference between a class method and an instance method when you see it being used? Here we're seeing it being used, not defined. Go ahead. Okay, tell me why. Okay, so what he pointed out, he said this is an instance method because he doesn't see static, right? Okay, correct assumption, wrong side. And I think you saw that when you started answering it. You said like, oh, so your answer you just gave deals with the definition of it, okay, right? Right here, we're seeing it actually being utilized, not written. Somebody else wrote this, dude, right? Whoever wrote the Toast class from the Android developer people, they wrote this guy. Okay, so we're seeing this guy being used. Okay, so it's a class method because it's being called by the name of a class, right? And how do you know that's correct? How do you know this guy's the name of a class? How do you strongly suspect? Perfect, perfect, perfect. Yep. Or yeah, it's not 100% rule, but it's super common. Class names typically start with a capital letter. All right, so we broke this down. We said this dude right here is a method. Then we want to know what kind of method it is. He said it's a class method. And I say, how do you know? Because we are calling this method with Toast, which has a capital T. So we suspect strongly that that's the name of a class. So since we're calling this method using the name of a class, it must be a class method, which means that, and we'll follow through here, which means that if we went and looked at the documentation and looked up make text, what should we see in front of it? If we went and looked at the definition of make text in the documentation, because we know this is a class method, we should see static in front of it, right? So we'll say Toast Android. That'll get us into the right. So here's Toast. Let's get us down to the, what does it not show us the, probably another. There we go. So we'll go down to, what's it called, make text. Make text, two different versions of it. We see static in front of it. That's seeing it at the time of definition. Somebody else wrote it. Somebody else defined this guy. If we were looking at this side and I asked you, is this a class method or an instance method? You'd say this is a class method. I'd say, how do you know? Well, it's because I see the word static here. That makes it a class method. This guy right here, is this a class method or an instance method? Instance method. How do you know? No static. Easy peasy, right? Okay, at the point of definition, when we're looking at the thing being defined, we can tell the difference between them, whether or not static keyword is there or not. All right, this is a page you've never seen before, but now we can read that documentation. All right, and that tells us how to call it, because he told us that since this guy has static in front of it, we will call it using the name of the class in which it was defined. And this guy is defined inside of this class called toast, the class called toast. So we call class methods written inside of toast by saying toast dot, the name of that method, which is what we're seeing right here. Toast dot, the name of that method. All right. Similarly, you've already told me that show here is a method. Now I'm going to go and show you make text here real quick. And make text down here, it returns an instance of toast. So it gives us something of type toast, which means this whole thing right there that I have highlighted will boil down to an instance of toast. So since it's an instance of toast calling show, what kind of method is show? Is it a class method or is it an instance method? Since we have an instance of toast calling show. Name kind of gives it away. Probably an instance method. All right. So that means if I were to go look up the function show inside the toast class, I should not find static in front of it, right? Because it's intended to be called using an instance of the toast class. Go down to show. Here's show, no static in front of it. And if you want to break this guy down into two lines, you can. We can say something like toast t is equal to this. And then we can say t dot show. So make text is a class method because we're calling it using the name of the class. It must return an instance of toast because we're storing it inside of a variable. In this case, we named it t. And now we're using that variable t to call show. You've told me that show is a method. It just happens to take no parameters, but it does have a parameter list. Guy must be a method. And we're calling it using an instance of toast. Therefore, he must be an instance method because of the way we're calling it. We can confirm that by going and looking at the documentation and seeing that the way it was defined is without the static keyword, which flags it as an instance method. You see how those two sides interject with relate to each other? And having this knowledge, being able to see both sides of it, being able to identify something when we're seeing it out here in the wild, it's wandering through the zoo out here, and we can look at this and say, I'm not exactly sure what this dude actually accomplishes, but I can kind of tell you what's going on here in terms of the programming paradigm at work. That makes sense? Because being able to do that means that you can read documentation, means you can look at code examples and walk through it. And these are important skills because sometimes you're going to go, if we're dealing with just plain Jane common logic where you're just writing an if statement or you're writing a loop or something like that, you might rely on your own just base knowledge and go and solve something. But other times you might say, okay, well, let's go see if I can find an example of something similar. And you need to be able to read that code and understand what's going on so that the next time you run into a similar problem, you're able to solve it. Because you don't want to become that person who just copies code and then randomly changes stuff until it works and not actually knowing what's going on. That makes sense? For instance, in the CSC250 class right now, systems programming, we look at C examples of operating system kind of code. And then their assignments are to, given your understanding of that, solve some other problem using the things that you learned in there as your starting point, as your tools. Okay, so they're not finishing something like we did here, where we kind of are writing our dice roller, and I'm kind of leaving us at at the end of a TV show or something like that, where you have a cliffhanger. It's like, now we got to find out what happens next, and you have to go write that for your assignment. In there, we're saying, understand the sample code that really has little to do with your actual assignment other than the fact it's showing you 2 or 3 new concepts that might be helpful in your assignment over here. And you need to be able to read that code and understand what's going on in order to use those same functions or same abilities in another program for similar but different solutions. All right. I cannot emphasize enough how what we spent the last 20 minutes talking about is the core of programming. Okay. The compiler will yell at you if you're missing a semicolon or something like that, and you'll fix it. You know, you capitalize the word if or something like that, it'll scream at you. You know, you don't go through your loop enough times because you said less than instead of less than or equal to. You'll figure that out. But if you can't look at code that's already been written, or you can't look at documentation and then go and put that to use, that's like you going to Home Depot buying something and either A, not reading the instructions, right, which most of us maybe don't do, or B, we're not looking at it and saying, how do we think we probably use this? And you grab a hammer, you look at it and you decide, okay, well, that thing that has the rubber thing on it, or the thing that looks like a handle must be where I grab it, right? The other thing seems heavy. It's probably what I'm swinging it for. What's this thing for? Well, I'm guessing banging stuff, right? So you kind of look at the tool and you decide, how am I supposed to use this? Same thing's true here with our documentation, okay? We have to look at it and assess how this guy likely works. All right, so in this case, show is a method, make text is a method. So in the big scheme of things, those two dudes are the same kind of animal, but they're slightly different in that make text is a static method or a class method. And we know that because we're calling it with the class name. Whereas show is an instance method. How do we know that? We're calling it with an instance, the class. Pretty much know this is an instance of a class because it's a lowercase letter, and good naming convention says that instances, variables, start with a lowercase letter. Classes start with an uppercase letter. So as long as we presume the person who's writing the code on the other end is using reasonable naming conventions, we can look at code like this and make a pretty good guess at what we would find in the documentation if we were to go and look at it. We would make the guess that show would not have static in front of it, and make text would have static in front of it. That makes sense? All right, so similar, and we kind of already answered this, but let's close this loop. This guy right here, length long. Don't look at the toast dot in front of it yet. Length long, just the guy I have highlighted there. What kind of animal do you think that is? Is that a field? Is that a constructor? Is that a class name? Is that a method? What kind of animal am I dealing with there? And why? Why do you strongly suspect that? There's two reasonable answers here, but in context, there's only one good answer. But two reasonable answers based on what I've told you to look at. You're only looking at what I have highlighted. What kind of animal is length long? Go ahead. Okay, it's probably an integer, okay? But now we're getting down to the kind of value it holds. So you've gone one level too deep. Go up a level. What kind? So it is an integer. I think it's highly likely it's an integer. We can confirm that when we go and look at the documentation. But what kind of thing is it? Is it a field? Is it a constructor? Is it a method? Is it a class name? Okay, it's a variable. What are variables associated with objects? What are they called? This is a variable. I've said it multiple times each time I'm giving you the list. Is it a field? Is it a class name? Is it a field? Is it a field? Is it a field? Is it a field? This guy's a field, okay? Classes are made up of three things. The members of a class are fields, constructors, methods. So whenever we're dealing with objects, those are the three things we find inside of objects. We find one or more constructors, well, technically zero or more constructors, because you could have a no argument constructor that does nothing, but all classes have at least one constructor, even if it's generated for us. We find fields, Okay, and remember, these aren't Java concepts, right? We did this stuff last semester in Python. When we created our objects in there, we had our constructor, which was called a init in there, right? We had the self dot stuff, those were our fields, and then we had some methods associated with our classes as well. So this isn't new Java, newfangled Java stuff, or even newer Android stuff. This is object-oriented stuff that's true across all object-oriented programming languages. You're dealing with an object. Objects are comprised of three different kinds of things. Fields, which are the variables associated with the object. Constructors, which are the method type things that are used to initially create instances of that object. And then methods, which give us the abilities, the behaviors, the things that these objects can do, either on instances or on the class itself. Does that make sense? So those are our choices. So this guy, the two reasonable answers here, what he actually is a field. The other answer you could have given, anybody want to come up with what's the alternative you could have given for this guy that wouldn't be necessarily wrong just based on what I have highlighted here? He starts with a capital letter, right? And we were told earlier that things that start with capital letters, at the very least, we should be suspicious this could be a class name, right? Okay, so just based on what I have highlighted there, if we're just kind of playing the game of, identify the mystery, right? We're kind of playing that game, and I look at that and I say, and I know this maybe, it seems like overkill, but I'm telling you this skill is the most important skill you can learn. All right, I think I've used the example before. I've been writing Java since it came out, which is way before you came out. All right, and I've probably only seen 10% of the language. So we rely on this skill of being able to read documentation and look at code examples and things like that and be able to see what's going on so we can put those things to use ourselves. Because there isn't a such thing as memorizing an entire programming language. We're going to learn the basic core components, the loops and defining our own variables and asking questions and that kind of stuff. But we still need to be able to look at other examples and look at documentation to pull things off. All right. So since we notice this guy starts with a capital letter, we might be suspicious it could be a class name. But since I see it being called with something else, that probably is going to tell me not a class name. This is one of the members of an object. So then I say, okay, well, since I know this is one of my three kinds of members of an object, it's either a field, a constructor, or a method, I'm going to say, well, can I rule anything out? I don't see parentheses. So it's not a method, not a constructor. Both of those dudes have parentheses, right? All right, so if it's not two of the three things, it must be that third thing. This guy's a field. All right. Now there actually is another interesting piece here, because this field, which is a variable name. So I mean, I don't want to shoot down that answer. Your answer is correct in that it is a variable. Just, I want to make sure we're using the right names for things specifically dealing with objects. This is a field associated with an object, which are variables owned by the object. But one thing you'll see in some other languages, and we actually see it often in the C class, the 450 class, is because this is in all caps, since it's in all caps, we might be lent to believe this is kind of a constant, a variable that doesn't change. And so this guy is probably going to be owned by the class, and he probably is also going to be in Java. It's called something called final, which means you can't change it. All right. And the thing is, I don't even know that for sure, but well, we know it's owned by the class because we're calling it with the class name. So we know we're going to see a static in front of it. But I'm going to guess this guy also has final in front of it, because being in all caps, the way it's being used in programming naming convention, typically all caps indicates that it's going to be something that's built in and doesn't intend to be changed. So let's go up to the field summary up top here. Yeah, see, it does not have final in front of it. If I click on length short, oh, no, it does. There's final in front of it. They just didn't get into enough deep detail on their top thing. All right, so it's static, owned by the class. It's an int, as you pointed out. Here's its name. Since it's in all caps, I suspected heavily that it was going to be final, which we haven't looked at that, but final just says you can't change the value. Once it's set, it's set. All right, questions, comments, concerns, bribes. So we should have some code here with some error checking and stuff like that. Go ahead. We do have, you have class tomorrow. I think classes, we don't have class Friday. So our next class, we don't have class. And I'm not giving you a homework assignment. And I think we also don't have class next Monday. Correct? Yeah, so that's a long Easter holiday. So the next time I'll see you is a week from today. But classes tomorrow, I believe, are on until 4 p.m. I think any class that meets after 4 p.m. tomorrow is you don't meet. I'm confirm that, but that's typically the way it works. The day before a break, any classes before 4 p.m. still meet. Well, if it's not, I mean, I don't know if it's a class. I'm just giving you my knowledge based on classes. If it's a class and it's after 4 p.m., it probably doesn't meet. But if it's a grad class, it probably does meet because they follow a different calendar. They follow the non-traditional calendar. All right, so I will see all of you next Wednesday. No homework, but make sure you really take to heart what we talked about today. This is super, super, super important stuff.